Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is find the polygon with largest perimeter. So the problem statement goes like this. You are given an array of positive integers of length n. Okay, a polygon is a closed figure that is having at least 3 sides, and the longest side is smaller than the sum of all other sides. Okay, so what the problem statement mean by this particular statement is, uh, let's say this is the polygon. Okay, let me take one slide larger. So let's say this is the polygon. Okay, now this is the longest side. Okay, let's say this is the longest side, although it does not seems to be the longest side. Okay, let's say the ordering is something like this. Okay, and let's even remove this. Okay, so let's say the ordering of sides is like this, and so what the problem statement is saying is sum of these three should be greater than this d. Okay, which is the longest side, and the sides should be greater than number of sides or equal to 3, at least 3. So conversely, if you have another way of telling that is, if you have k number of sides and k is greater than or equal to 3 and all the sides are positive real numbers, and this condition holds, so they are in this order. Okay, this is the same order that I have just wrote here. Okay, so sum of all the 3 sides except this particular side should be greater than the last or the greatest side. So a plus b plus c should be strictly greater than d. Okay, these two conditions are there, these 3 conditions to be specific, the number of sides should always be at least equal to 3. So if these conditions are there, then you can say that this is a polygon, and the perimeter of a polygon is length, sum of all the sides. So perimeter will be a plus b plus c plus d. Okay, and we have to return the largest possible perimeter of a polygon whose sides can be formed by this given nums array. Okay, and -1 if it is not possible to create a polygon with the values of the elements taken as values of sides of a polygon. So let's have a look at the constraints also before proceeding with thinking about the solution or the approaches that could solve this particular problem. So the number of entries in the nums array, you can say, is of order 10 raised to power 5, and those entries are ranging from 1 to 10 raised to power 9. Okay, now with that out of our way, let's see what kind of approach we can use here. Okay, so first of all, this condition can be easily satisfied if, let's say, we decide to sort the nums array. Okay, this condition can be easily taken care of with the help of sorting, and since sorting takes up n log n, where this n is the size of the nums array, and as mentioned in the constraints, it's of order 10 raised to power 5. So this thing will not generate TLE. Why so? Because these number of operations are lesser than order of 10 raised to power 8. So this is a operation limit, if you may ask. If the number of operations in your program or that your program will be requiring to solve a particular problem is less than this limit, then your solution will be getting accepted. So this condition is satisfied. You can consider it satisfies as of now, since sorting will be taking care of that. And if the sites, this can be easily checked also, whether the size of nums array is greater than or equal to 3, or let's say the size that we are checking for the polygon length that we are checking is greater than or equal to 3, then we'll say that okay, it's a valid polygon and we'll check for it. And the third condition is the main condition that is required to be given some serious thought about, like how will we managing to you can say check this in a most efficient manner that can be there, this particular condition. So since we have already sorted the array, let's say the nums array was given something like this: a c d e, or a c d and b, and the ordering was like this. Okay, so if the ordering is like this and your nums array is given to be this, then if you do the sorting, then it will be after sorting a, b, c and d. So what you can do is you can take a running sum here. What I mean by running sum, let's say we mark the indices 0, 1, 2, 3, and then if we are at the 0th index, then its running sum will be running sum. Okay, as a, and if we are the second index, then it will be a plus b, and if we are the third index, it will be a plus b plus c, and if we are the fourth index, a plus b plus c plus d. Okay, so that condition, last condition that or the first condition that was requiring us to always have sites, number of sites greater than or equal to 3, can be easily checked here. Whenever your index, let's say these are the indices. Okay, whenever the index value happens to be greater than or equal to 2, you know that the number of sites is greater than or equal to 3, since it's a 0 based indexing, so that's why. So whenever this condition is satisfied, and you will be simply you will be keeping a variable, you can call it max perimeter. So you will be simply you can say checking whether the condition holds true or not. What condition I am talking about? Let's say you are at the second index. Okay, so the side represented by second index is c, so this condition should hold true. So a plus b should be greater than c. Okay, or more specifically, if you may ask, it is if let's say you are at the second index, it is nums of second, and this particular thing, if let's say we are putting running sum in a array like structure, okay, and marking the indices, so it will be nothing but running sum index minus 1. just one index previous. Okay, will give us the sum of the all of the sides which are other than the longest side that is there. Okay, so this will be sum of all sides except longest side. Okay, so this will be this value. If this condition holds true, you will keep updating your max perimeter value. Max perimeter value will be updated. Okay, whatever was the value previous to this particular condition being satisfied, and this one also, and the value that is at the current index, which is 2 of running sum. So running sum value at the current index. Okay, so you will just keep updating your max perimeter value when these conditions are satisfied. What are those conditions? This is one, and this is the second condition. If these two conditions are taken care of, then you can say that we can update the max perimeter value, since this condition that all of them should be in sorted order is already satisfied by the sorting itself. So that is how we will approach towards solving this particular problem. And without any further delay, let's see the implementation of this approach. So this is the implementation. Okay, we have done sorting in order to keep this satisfy this condition that all of the elements should be in increasing order. So once that is out of the way, we will be using prefix sum. Instead of running sum, I have just renamed it to prefix sum. Or if you may want, you can also call it running sum. That's not a big issue here. So let's call it running sum. Okay, and the size of the running sum structure, or let's say the array that we'll be using, is exactly similar to equal to nums. So that's why we are taking size equal to nums array, and this is the maximum parameter that we will be returning. And this is how we populate running sum. If you are at the very first index, then it's only one value, which is the value of nums present at that index. And if it's the second index, then what you will do, you will take whatever is the value currently at nums, which is b, and one value previous for running sum, so it will be a plus b. Similarly, if you are at this particular index, you will take whatever is present in nums array at this particular index, which is c, and one previous value of running sum, which is a plus b. Okay, so that is how this running sum is populated. So till here we are just populating our running sum. Okay, and then we are checking that condition if we are inside a polygon or not. Okay, if we are inside a polygon or not, or you can say if we are forming a polygon or not. If that's the case, then we'll update our maximum parameter and we'll be returning whatever is the value of maximum parameter. If let's say value of maximum parameter is 0, it indicates that polygon cannot be formed with the values given in nums array. So in that case, you will be returning -1 as mentioned in the problem statement. And if that's not the case, you will simply be returning your maximum parameter value. So that is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.